All right, so what we're going to look into today, we're looking at factorizing things and the reason why factorizing is so important with quadratics, which is what we're doing now, is the way we get, when we're graphing quadratics, the way we get the intercepts on the x-axis is by factorizing our equation. So this is why we're factorizing at the moment, and we're learning how to do it. All right, so when we're factorizing, I want you to always think about these steps when you're doing it. And this is going to become vital and very important all the way through all your maths, and make sure that you're doing it. So the first step when you're factorizing is look for a common factor, and we've been practicing that. So we looked for something that was in both of them and we take that out. You should always look for that first. So once you do that, if you can, you do it. If you can't, at least you've looked for it, and you then move to the next step. So then the next step is you might look to see if you have one of these patterns. Now we looked at these patterns the other day, and what we looked at was more that we expanded it. So really, when we expanded, this was expanded form, and this is factorized form because it's in things that it's in the factor. This is factorized. Okay, so now what we will be doing is we will be seeing it in the expanded form and want to know that it can go back to that with the pattern. All right, and the same down here, we had these. This is the factorized form here in the purple, and over here is the expanded form. So we would be looking to see if we've got that expanded form and we want to factorize it, meaning we want to go back to it looking like this. Okay, so that will be the second thing that you will look at when you're trying to factorize things. This third method here, when we talk about the cross method, we'll learn about that later on. So that would be your next option to do that. And then there's some other things we can do, which you'll probably learn in later years, okay? But really important that in the beginning that you learn that you've got to look for all of these things first. It'll make your life easier. All right, so we're going to come down here. Now, it says factorize each of the following expressions. I'm down here, using the difference of two squares rule. So I've popped that up there. That's that rule. So remember, we are now in, these are all in expanded form, and we want to go back to factorized form. So what you're doing is first we should look for a common factor. So first look for a common factor. So what I mean by, is there something common in these two terms? Yes or no? Is there something common in them? Boys? No? I'm going to say no. All right, so there's nothing that they both got in it. So I've done the first step, there was no common factor. So now I'm looking for a pattern, which they are telling me anyway in the question, which pattern to use. All right, so what I want to do is I want to write this expression here, and I want to write it so it looks like the pattern. Now, can 25 be written as a squared number? I'm going to ask someone. Yeah, good work. Who was that?
Max.
Well done. So we can say 25 is like 5 squared. So can you see that now this looks like this squared term minus another squared term? It looks like up here when we had a squared minus b squared. So we can go back and we can factorize it and write it in factorized form. And we know if we went back, that would actually be x plus 5 and x minus 5. Okay, so here now is my final answer. This is factorized. All right, so then we look over here. We'll do the next one. So first of all, I look for no common factor, and I'm just going to write there no common factor. So now I'm looking for a pattern, and we know there's going to be the difference of two squares pattern. So I'm going to ask Daniel, can 81 be written as a squared number?
Yeah.
Yeah, what would it be?
93.
Good. So what would this, if I go from expanded form back to factorized, what would the factorized form? Can you see the pattern? Do what I did before?
X squared plus 9 and x minus 9.
Yep, good. It'll just be x plus 9 and x minus 9. Yep, not squared, but yeah, good. All right, so I'm going to ask Liam Oxley, can you do this last one for me? See?
Yes, there's no common factor, so you turn it to a squared minus 4 squared.
Beautiful.
And then you do a plus 4 in brackets and then a minus 4.
Excellent, well done. So these have all been factorized. Excellent. All right, so I'm going to move on to the next page. All right, now these ones, you've got to remember still the rule. When you have a squared minus b squared, that factorizes back to a plus b, a minus b. Now it doesn't matter if you look here, this is the squared term. So this is like the a up there in the pattern. This whole little expression here is like the a, and then this bit is like the b squared. So what I'm going to do is first, this is already in a squared. I'm going to change 16 to be 4 squared. So if I want to go back to writing it in factorized form, what you do is you write your first one, which would be x plus 9, and then one option is I add 4, and then the other one, x plus 9, the other option is I minus 4. So what I've done there, see, this is like the a bit, so that's like the a, and this 4 is like the b. And you can see I've minus there and I've plus there. Okay, now because you can add 9 and 4, we do that. So we go, it's 13, and we can subtract 4 from 9. So I'll have x plus 5. So that's how these ones end up being. So if I go up here to p plus 8 squared, Marcus, how would I write 25 as a squared term?
Would it just be 5 squared?
Yep, beautiful. So do you think you can do out the brackets now? Factorize this?
So would I have to would it be P8 plus P8 minus 5?
Yep, that's one option.
And then P8 is it?
It's P. 5? Yep, good. Awesome. So it doesn't matter which one goes, as long as one, as long as one is minus. So I'm talking about this bit here. One needs to be minus and one needs to be plus, like up here. Okay, and then we can do that because P8 minus 5 is 3 and 8 plus 5 is 13. So there's our factorized form. Now when we've got the letters here, I'm still just going to do the same. It'll be P minus 2. One time it'll be plus Q, and then it'll be P minus 2. One time it'll be minus Q. And that's all you can do because there's no there's no like terms there, so we just keep leaving that one. All right? So we get up to these ones. So I'm not going to do all of them, so I'm just going to delete these ones underneath. Sorry, just do some with you. So you've got today and tomorrow, the other lesson on Thursday to do these. So don't stress. I'd rather you understand it first. So here, when they ask me to factorize this, you see they're reminding you at the moment to first remove any common factors. So if we have a look here, there's a common factor of 2. So if I take 2 out, I'd be left with m squared minus 16. All right, is everyone happy with that? Do you know where I got that from? Yeah, everyone's happy? I'll pop the little step in between just to revise you. So this would have been 2 times m squared minus, really, I can say 2 times 16. So I've taken 2 out and I've left with, that's why I've got m minus 16. All right, now you keep leaving this 2 out here, but what we're really dealing with now is what's inside those brackets. And I've got m squared, but I can write 16 as 4 squared. Okay, so now inside this, and I'm talking about in here, I'm going to use the pattern that we've been talking about, that we know that a squared minus b squared factorizes out to a plus b, a minus b. Okay, so I'm going to do that, and that would be m plus 4 and m minus 4. They're my options. So once you've done that, you just then pop it in. You don't need those other brackets there. I was just showing you, I put them there so you can see that I'm working with the inside of it, the m squared. So we do that like that. And here's my final factorized equation or expression. All right, so up here, the common factor is 5, and we've got to take that out first. So if I take 5 out, I'm left with y squared minus 9. Okay, now 9 can be written as 3 squared. So I see that that is one of the patterns, and then I just factorize it to y plus 3 and y minus 3. All right, up here, the common factor is 6. So I'm taking that out first, and I'm left with that. And then I'm going to change 4 to be 2 squared. So then it is p plus 2 and p minus 2. Okay. So at the moment, they're telling you all the steps. They're helping you, remind you, because you're only learning, so it's really important. But it's important to remember in your head to always look for the common factor and then to look for the patterns. It makes it very hard in later years if you forget that. It's just becomes, some questions become nightmares when they didn't need to be. All right, so we want to try to always have this in our memory. Okay, now we're up to factorizing. We're still factorizing, but we're using this perfect square rule. So if you remember, this is factorized form, and this is expanded form. Okay, so we're going to go from this back to that. So what we want to do is to be able to spot this when there's this pattern there. So if you have a look down here at the first one, if I wrote this out, I could write that x squared, I could write that 10x is the same as 2 times x times 5, and I could write 25 as 5 squared. Now, can you see that that is this pattern? See how it's 2 times the a times the b? And that's what I have there. I have 2 times x times 5. So I can see it's one of those patterns. So all I have to do is go, all right, then this factorizes to x plus 5. Now I can either write it as 2 of them, or you can just write it as x plus 5 squared. Doesn't matter. So up here in the second one, I can see that 24 is actually 2 times p times 12, which is good because 144 can be written as 12 squared. So that means it looks like this pattern here. So I can factorize it, and this one will be p minus 12, or you can write it as p minus 12 squared. Doesn't matter. It won't matter if you write them both or you do it like that. So if we look here, 100 could be written as 10 squared. So this middle number is 2 times n times 10. So yes, it's one of the patterns. So I'm going to write it's n plus 10 squared. Remember that the symbol that's here is coming from that. Okay, so this one's a plus, so that one's a plus. Okay,